All right. Good afternoon, ladies and gentlemen. I hope you enjoyed a nice lunch break and are ready now for our next presentation. There has been a question which has puzzled me for a while. Why on earth is it so difficult to properly manage the coolant? And why is the reputation of the coolant so bad? So I was able to visit and see some customers around the world, and I saw very interesting things. And I would like to share some impressions of my adventures to you. So let me share the screen. So here the first picture you see, that was in China, yeah. That was a machine tool builder in China. So you see clearly a lot of residues, dirt and mess in the machine. And this is quite common to see at customers. So that's not a big surprise. But then let's go ahead. This one was a job shop in South Korea. A very busy company, had a lot to do and no time to take care of the coolant, as you can see. And then we can also go to Europe. Similar pictures here. Even in Switzerland, you see something like that. So that was a mold and die manufacturer in Switzerland, and yeah, coolant completely neglected. Then last but not least, here a very interesting nice view on coolant from an automotive company in Germany. So my question is, how on earth can you let your employees work in such an environment? This is really the question I have. So I claim that every production can benefit from an easy use coolant monitoring, and that this is possible to implement in only one day. Today I will talk about smart coolant management. My name is Daniel and I'm the head of sales and marketing of Liquidtool Systems. 20 years ago I got my first contact with coolant and got a coolant shower in the shop floor when I did my apprenticeship. So that was what we were doing. We were using the coolant as a thing to annoy each other. However, this didn't push me away out of the industry. I stayed in the industry because it's so amazing, so interesting. And now we're able to shape the future with digital solutions. And as you saw before the pictures, there were quite obvious issues with coolant, and obviously also no one took care of them. They were just there. At the end, you saw the problem. But there are less obvious issues with coolant, which have an even bigger impact on a production. And therefore, I would like to dig a bit deeper into coolants and specifically into the concentration of coolant. So I prepared a little flip chart here for you. So you can see that. Yep. All right. So every coolant or every manufacturer of coolants has to provide a product information data sheet. And in there they say what is the maximum allowed concentration and the minimum, so the coolant stays stable and happy. Let's put it that way. So that's the theory you have to work in. Huh? In reality, I mean, you saw the pictures, but also many other places when I measure concentration at customers, I realized that customers struggle really to stay in this bandwidth. What happens? The water evaporates, and so the concentration goes up. less water, more concentrate. So we end up in this area up here. And that's the danger zone of the coolant. I have some pictures because it's easier than painting. So one obvious point when you have a too high concentration is clearly that your coolant consumption is just unnecessarily high. You waste a lot of coolant and there's no benefit on it. Then a bit a more serious topic is skin irritation. So the higher the concentration is, the more active substances are in the coolant. So there are also, depending on the product, obviously, more aggressive ingredients which can harm your skin. And then with a high concentration, you also risk to provoke a foam behavior. So foam is really bad in your process. If you cool with foam, you never achieve the same cooling effect as with pure water, or you will never have the same lubricity as a proper emulsion. So these are issues you can have when you're too high. So then you measure you're too high, then you say, okay, I'll fill up with a bit a thinner emulsion, and then you drop down, let's say, let's put it a bit lower so it will rise anyhow. So we give ourselves a bit safety, and we end up here in this other danger zone. So this other danger zone brings other issues to the table. And there I want to start with, so when you're below the lower limits, the coolant gets unstable. And when it gets unstable, the bacteria can start growing in the coolant, and this causes a very interesting smell. So not a nice one. I have seen that everywhere. Whenever you go in a shop floor and you smell the coolant, you know these guys, they don't have it under control. It's a very easy measurement, your nose. Then, when you have a low concentration and an unstable concentration, the coolant dies within time, and you can't fix it anymore. So the worst case comes, you have to stop the machine, pump out all the coolant, clean it very thoroughly, because if you don't clean away the bacteria in the machine and fill it up again, the bacteria is already in it from the beginning. So it's like a half-day hard work until you can go back into operation. Then with low concentration, you obviously have also less ingredients helping your tool wear. So your tool wear rises and you waste a lot of money on tools. And last but not least, the corrosion protection. So the lower you are, the less corrosion protection you have in your emulsion or in your coolant. And there you risk to have corroded machines. And yeah, no one wants to experience that, obviously. So as you see, we have a danger zone up here, a danger zone down here, caused by the wrong concentration of the coolant. But there's more to this story than just these two limits. So if you look at this bandwidth here, so you might say, oh, it's just plus 2% coolant and minus 2% coolant. But in reality, if you ignore the percentage and just look at the absolute value, it looks very interesting. So here, let's say 7% is the target you want to have. And the bandwidth from 7 to 9 is, if you calculate that, in absolute figures, it's 28% more active substances when you have 9% than when you have 7%. And now you can do the same story down here. Very simple. So if you go from 7 to 5, you have 28% less active substances in your coolant. So the aim of many customers is to be here. But if you really want to win something, you have to narrow this down. So much to the concentration. So, oh, sorry. So, in a short summary, the concentration and temperature of the coolant have the highest influence on the machining process. And the lower you can get this curve, the higher is your process reliability and the predictability. What I'm trying to say is that it is like a rope walk. If the concentration is too high or too low, there is always trouble awaiting you. And you need to find your sweet spot for perfection. And then you have, if you go a step further, then you have an individual situation on each machine. So if you do want to get the maximum out of every process, out of every machine, you have to look at them individually. So here, as an example, you have a first machine with 11%. Let's say this machine only machines titanium, has a special coolant for that and is adapted for that. Then the second machine on the top right, grinding machine. With grinding, you have a lower concentration, otherwise the process doesn't work. And maybe you even have a special grinding coolant. Then the third situation, a special machine with 6%, a third type of coolant. Then you can go with the same coolant with a bit higher concentration on a universal machine. And last but not least, a conventional machine. You also need coolant and you also have to take care of it. So you have many different situations you have to take care of, and every situation is different. So this complexity and this potential motivated us to create a solution, an easy solution for the market to really save a lot of nerves and a lot of money. Let me walk you through this solution. So what we have is a precise sensor, and it measures in tight time intervals the concentration and temperature. These values are then continuously documented and are anytime available on the cockpit, as you can see here on the right. So if you wish, you can get real-time notifications with clear and easy to understand instructions, which help you or your employees to correct the situation in the fastest, easiest way. Additionally to the automatic measurement, you can also add manual measurements. For example, you could do manual pH measurements and add this to your documentation of every single machine. Like that, you have the concentration anytime under control, and all relevant values are documented by machine, a clear history, and this helps you to see and hear the coolant. So for us, it was important that we create a solution which works everywhere and for anybody. Therefore, the sensor works in any type of coolant. I'm talking about water miscible coolant and any machine. Like that, you can use it in a whole shop floor. Doesn't matter what kind of coolant, what kind of machine you have. So in this whole solution, you can even integrate not connected machines. So for instance, you have here on the top connected machines with a sensor, automatically measured. And below you have maybe some conventional smaller machines. You don't want to invest money into it, so you say, okay, I'll just document it manually in the same solution and have all my machines in one overview. The solution can go, the architecture behind the solution can go so far that we could represent the firma, the company Bosch, for instance, or any other large multinational company. It is possible to have different sites, different production floors, different departments, different cells, different machines. So you can have your hierarchy however you want. You can build that up and have an access on every level however you choose. The right person has the right access for the right data. Then what was really important for us was the freedom of choice for the customers. So we don't want to lock in the customer into a situation where he can't get out anymore. We want to create an open platform which allows him to start somewhere and continue going forward. So here as an example, we have on the shop floor, we have interfaces like IO-Link, MT-Connect, OPC UA, that allows our devices to talk with other devices on the shop floor. Of course, the other device also needs the interface, otherwise it doesn't work, but we say we want to be open and give this possibility to the customer. Then we also want to make sure that our connection to the platform is not only open for our devices, for Liquidtool devices, that it's also open for any other device which has interest in adding data on this platform. So that's the second part of the story. And what we're doing right now at the moment is we're creating a hub where we can connect our platform to other platforms. And that's when it gets really interesting, when you can combine all this data from different platforms together and learn from the combination of all the information which is available, and then improve your situation wherever you are. So, I promised you that every customer can be digitalized in one day, and I will prove how this works. So imagine this here is your machine. So that's your machine. So to any machine you need a coolant tank. That's this. That's your coolant tank. Now, how do we continue? First of all, we need a filter. The filter goes into the coolant tank, into the coolant. And then we have another hose to bring the coolant back into the coolant. Then we come to the key part, the sensor. So the sensor works very simple. We have on one hand the filter here. You plug it in. Then in this sensor there's a little pump. This will suck the coolant into the sensor and measure it directly in here. And after the measurement, it goes back out into the coolant tank through the smaller hose into your tank. So now what's the next step? We have to install it on the machine. Okay, let's install it. Done. Easy magnetic mount. You can place it wherever you want, as long as you have like a sheet metal or something magnetic in the background. Then the only thing you have to do is turn it on, and then it will boot up because there's a little computer inside. While this is starting, I will also show you this NFC token. So NFC stands for Near Field Communication. And we said we need to make sure, normally you have the sensor at the back side of the machine where the coolant tank is, and you work in front of the machine. And then when you want to know what's the concentration on your machine, you don't want to go back there or anywhere. You want to have the information very quick and easy. So therefore, you can hover with your smartphone over the token, and this will open, I can show you in the camera, this will open the present values you have directly on this machine individually. So every machine has its own token. You can go from machine to machine and read individually the values very quick. So now it's started already, and obviously it's not set up because we only have water over there, but that's simple, installed, plug and play coolant management solution. So, for me, the answer to the question asked at the beginning is pretty clear. The reputation of coolant is bad because you can't understand it. It doesn't matter if the concentration is high or low, it always looks the same, it feels the same. And therefore it is important to make it visible with data, something like that. So you can understand your coolant and take the right measures to improve your situation. So for me, it's clear coolant has been for a very long time a very blind thing. First of all, it's chemical. So in the mechanical world, most of the people, they don't like the chemistry. I understand, I'm the same. But now, as soon as you see data and you can feel and touch and understand the coolant, you can really learn from it and use this information as a weapon to improve your process, your productivity, your situation, that all your people are in a safe and clean environment, that they're motivated to work. So we are very excited. We just launched this year, January, and we'll launch many other countries this year. So we will have an exciting year, and looking forward to meeting all the different markets out there. I hope there are many markets here in the presentation. And I would open the floor for questions. And I will just check if you wrote questions as a chat, but you can also unmute yourself and just ask questions if you feel comfortable, or just write a question in the chat. So please feel free to ask. And now we have this shy first 2 minutes, I get that. Any questions? Let's go here. Pricing is always a topic. Of course, that's always a topic. Yes, thank you, Peter, for your question. So you're curious what this costs, I guess. So that's a very simple to answer question. First of all, you can also inform yourself on liquidtool.com. We'll have the prices there transparent, and you can look at them and you will see the availability. We're talking about a subscription cost of 600 Swiss francs a year per machine. And at the beginning, you have an investment cost on the sensor device you need. All right. Any other question? Is there any option of a monthly fee or is it one shot? No, as I said, it's a subscription, a yearly subscription you can have for the whole solution, and a one-shot solution we don't have so far. Looks your discount structure. Yeah, we have a volume-based discount structure. This is also available on the website. So the more machines you want to monitor, the cheaper it gets for you. Any other questions? Let's see. Is it only checked on concentration value? Is it right? The automatic measurement with the sensor is concentration and temperature, because these are the two most valuable the values you need for your process, and any other measurement you can add manually. To improve the sensor also for pH and FH. I'm not sure if I understand FH, but I understand pH. So of course we're thinking of further measuring automatically all values. What was very important for us is to create a plug-and-play solution. So the technology nowadays for pH measurement is quite let's say the maintenance for it is quite high, and we didn't find the right technology yet to measure the pH value in a very simple and easy, safe way. Therefore, we said, if you measure the pH value once a week with the strips, that's good enough, but you can add the values to your data, to your cockpit, and you have everything then together. Then, do you think to improve the sensor are going to have that? Someone is typing. Joma. Curious. Oh, I saw that Stuart is in the chat. Do you have any questions for us, as you are an expert in this field? Okay, next question. Could the system provide any prediction on the remained coolant life? That's a very interesting question. The prediction, I mean, every coolant is so complexly and so different. This will be a challenge to say yes, but what we can say is the more we learn with this data, the easier it is to predict how the performance and the lifetime will be of a coolant. So what we can say is the closer you have this concentration bandwidth and the more stable you are in there, the longer your sump life is of the coolant. But every coolant is different and every situation is different. It's an open system, and you can get a lot of other factors into the coolant. So as long as you take care of the coolant generally and have it in a tight bandwidth, you can prolong the life massively. What key performance is used? Prediction remained at knowledge. Cool. So, yeah, the key performance is time of concentration level in the right position. So the longer the concentration is out of the bandwidth, the more likely the coolant gets damaged and has to be replaced. The bandwidth is a standard for every coolant, that's true, but every coolant has a different bandwidth, that's for sure. But the bandwidth is only for the actually to take care of the coolant, and has not a big influence on the process. I mean, meaning for the process. Is it able to read only emulsion value, or should be influenced by the guide oil? So that's also a very interesting question. Yes, the guide oil is always an issue for coolant. Absolutely, and this has also an influence on the pH. So what you can do regular checks, and also mention that in your solution, that you have this checks and see if you have a lot of guide oil in your emulsion. So this is never good. You always have to get rid of the guide oil anyhow. Otherwise, you will end up with an issue. Thanks, Stuart. Kind. I am very happy that there are so many questions. This makes this very interactive. I wish we could even change to the audio part, so you could also talk. Okay. Looks like the questions are coming to an end. Let me just see. Oh no, that's another question. Nice. Could you explain more about the cloud data storage duration? Who own the data? Okay, that's an important part. So yes, the data is saved in the cloud. We use the Azure IoT cloud, and the owner of the data is always the customer. So the customer always decides if the data can be seen or not, and be seen by whom, which is very important. Obviously, our solution only works if the data is shared. So that's a bit this tricky situation what we have in our industry. I get that. But I think we are now 2021. We have to go a step ahead. And we have to invest a lot in data security. This is very important to make sure the data, to make sure that you can benefit from gathered data and bring value back to the customer, and not only just harvesting data. That's not the aim, but yeah, it's a very good question. And the duration I can't answer because I don't know by heart, but we have that in our privacy policy mentioned. You can read that there. I'm sure we have it there. Any other questions? Anton is asking more. That's good. All right, you're welcome. So let me. Okay, so I think all the questions have been asked. Thank you very much for your attention and for your many questions. That makes this much more interactive and interesting. Please also visit our booth. You could play around with our chatbot, William, and train also his brain with data. So the more you challenge him, the more intelligent he gets. So we are looking forward to that. And if you have any other question, also we want to get in contact personally. My data is available on liquidtool.com. And I'm looking forward to your questions and exchange. We'd love to go the next step with you in the digitalization and the Industry 4.0. So thank you very much for your attention. Have a great afternoon. Enjoy the other presentations, and hopefully see you soon somewhere in the physical world. Thank you.